Hello everyone, this is week 1 and we are studying Python and neutral nets. Today I'm going to be talking about the first out of 4 courses in Deep Learning AI's AI Python for Beginners course, what a neutral network is, and what the universal approximation theorem is. In short, computer programming is a set of step-by-step instructions that a computer follows to be able to perform a specific task or a sequence of multiple tasks. For example, a person following a recipe on how to bake a cake or following a manual on how to change a car tire is like a computer following code instructions to successfully finish its task. We learned that computer programming has helped the advancement of humanity by creating computer programs that serve many different purposes, especially to help us communicate with one another and deliver various services to others. We also learned that data in computer programming can also be stored and represented by characters and numbers. For example, we can store text, numbers, images, and even sound in computers. Images are stored by a matrix of numbers, where each pixel contains numbers that represent how intense the colors of red, green, and blue are in the pixel, which are also known as RGB values. Sound can also be stored by numbers, or various rapid variations of air pressure. These measurements of the air pressure are stored as number values in a computer as well. In this course, we used a built-in AI chat box to learn the basics of Python and ways we can use the chat box to help us learn with our programming. AI can be useful when you're stuck and not sure what is wrong with your code or if you're unsure of the next steps. They also have the ability to answer any follow-up questions if you need more clarity or explanation to the solution of the problem. For example, in the top picture on the left, I asked the AI chat box to help me fix a simple print code that had an error in it. It returned the corrected line of code and gave me the option to copy and paste it into the program to successfully run it. In the bottom picture is an example of me asking the AI chat box to clarify what an error means, and it provided an explanation along with another example of what other mistakes could cause that same error. Another practice problem that I did in the course had us input the print LLM function, which took a large language model and allows programmers to write various functions as if they were talking to the AI chat box inside of the program. As you can see in the picture on the left, I typed out a print function as if I was asking the AI chat box to give me a recommended song based off of the existing variables I had already created. Next, we're going to be answering the question, what is a neural network? A neural network is a computing system that is meant to replicate and simulate the way the human brain analyzes and processes incoming information. It consists of multiple layers with neurons that act as nodes that help process and send information throughout the network using math equations and activation methods. Each layer has its own responsibility and role in processing data, which we will get to in the next slide. Throughout the layers, each neuron is connected through weights and biases, which are constantly adjusted as the computer trains and learns to recognize patterns. The computer then activates specific neurons based on its value, which represent the details of the final image. The first layer in a neural network is the input layer, where it contains 784 neurons, which is usually a 28 by 28 pixel image that represents a pixel with a value of either 0 or 1. The hidden layer usually has 2 layers containing 16 neurons each that use a sigmoid function to determine its activation by calculating the weighted sum and attaching a bias to determine the different features of the image. For example, if the computer was trying to recognize a number, some of the features it would try to recognize are the loops, curves, or edges of the number. Like the number 5, it has edges and a curve, but it does not contain a loop, while the number 8 would contain 2 loops making up each half of the number. In the output layer, there are 10 neurons that represent digits from 0 to 9, and it returns the network's prediction based on the activation of each neuron from the hidden layers. The sigmoid function that is used in the hidden layer takes the value and squishes it into a value between 0 to 1, which makes it easier for the neurons to determine its activation based on its value. Lastly, we're going to be talking about what the universal approximation theorem is. The official definition of the universal approximation theorem is the feed-forward neural network with a single hidden layer containing a finite number of neurons that can approximate any continuous function on a subset of inputs to any desired degree of accuracy, provided that the activation function is non-constant, bounded, and continuous. In simpler terms, the theorem allows computers to learn and solve continuous patterns if they have enough neurons. The piecewise linear approximation concept is a good concept to understand for the universal approximation theorem because it breaks the graph down into smaller parts, which are then approximated and represented by straight lines. The more lines there are, the more accurate and better the approximation is. This demonstrates that even with one hidden layer, neurons can use its activation functions to determine continuous patterns.